Hi guys. So just wanted to share about this particular concept of Groq that comes up with this inferencing technique that makes our generative AI tools faster. So I think while building generative AI tools, we tend to talk a lot about challenges like hallucination, data privacy, even the accuracy of the model. But we most of the time miss out on this particular topic of inferencing time, or you can say the inferencing engine that is being used in the backend while making this particular generative AI tools. And that is something, I can vouch for it after working for more than a year in this field of generative AI. We tend to miss on this particular topic of inferencing engine or inferencing speed. So, okay, let me just explain what inferencing actually is. So for example, you have this particular model. It can be an ML model, deep learning model, or let's consider it's an LLM itself. So in this particular LLM or in this machine learning model, we gives an input. Let's say it's an A. Then there goes some processing, whatever we are asking the model to do on this particular input A, and it outputs B, let's suppose. So the time taken by the model to take this input, do the processing, and output B is called inferencing speed. And what is being used in the backend is the inferencing engine, we basically see. So that is what inferencing speed is. So let me just do the comparison here. So here I have loaded this both the machines, and the left hand side this is the playground of that is being provided by Groq itself. Here I'll be using the model Llama tree, 8 billion parameters, and the right hand side I have obviously ChatGPT, that I'll be using the latest model from OpenAI, that is GPT 4o. So let me just ask a question. What is quantum mechanics? We'll do the same here. What is quantum? I hope the spelling is correct. Quantum mechanics. I'll push it here. Just see the speed, okay? See, Groq has already generated its output, and GPT-4o is still doing its job. It is relatively slower. Obviously, GPT-4o is relatively slower. GPT 3.5, I would say it is still faster than this one, but look at Groq. It just produced 1200 tokens per second, literally 1200 tokens per second, and it almost took, I think, 1.2 seconds to do, you know, to generate all this text. So the speed is insane, as we have already seen. And I have also loaded this, particular code. Just quickly, I have loaded the code by leveraging this library from that Groq itself provides to use chat completion. So I'm just giving even more complex summarization now. I'm giving this particular text that is not formatted nicely, and it has basically information about standardization and normalization that we have in machine learning. So I have this text, this huge text, and I'll ask it to summarize the text inside the braces. So I'll just run it. To use it, you must have the API key itself, and I'll just show you how to create the API key as well. I'll just run it. See, it just took 1.8 seconds to do the summarization. That is insanely fast. And I'll also talk about the magic that is going behind to have so faster inferencing. So see, the normalization is a process applied in various fields such as statistics, database design, so on and so forth. Standardization also, it's normalization and so on. So it is so fast. So let me just go to the website itself. So Groq is basically a company, so that has come up with this new inferencing engine that is called LPU, that is language processing unit. So an LPU inference engine, with LPU standing for language processing unit, is a hardware and software platform that delivers exceptional compute speed, quality, and energy efficiency. This new type of end-to-end processing unit system provides the fastest inference for computationally intensive applications with sequential components such as AI language applications like LLMs. So that's the magic behind. So it is not using any CPU, it is not using GPU. This LPU is a processing unit itself, but it is even faster. It is even surpassing GPU. So that is the magic behind that is going on, and why it is so much faster than GPUs for LLMs and Gen AI. So the LPU is designed to overcome the two LLM bottlenecks: compute density and memory bandwidth. An LPU has greater compute capacity than a GPU and CPU in regards to LLMs, and you can just read all the text. So basically, it is using LPU in the backend, that is language processing unit. So if I'll just go ahead with the documentation, so this is the documentation of Groq Cloud. So here you can see how you can quickly start with the API of Groq. So you will have to pass the API key, then installations, and this is this code. You can just quickly do the chat completion. So here in the model section, you can see all the models that we have. It has also the Llama 3.140 billion parameter. That's the latest model from Meta as well. So these are the models you can see here. Then if you just go down, and here you can see the integrations. Here you can see the Groq libraries, and again Groq can be integrated with any generative AI, developer tools like Versal AI, LangChain. It has all the integrations. Is great, is great. So again, to create the API keys, you can just go ahead here, click on your create API key, give a name and submit, and you will get the API key and do all the stuff. But that's just for a personal purpose. But if it's a enterprise access you want for commercial use, these are the rates we have. That is, for example, for the model Llama 3, 80 billion parameters, that has 8K context length. So the speed, it is 330 tokens per second, and even the price is quite reasonable as well. So you can find all this information in documentation itself. And let me just share this one. Just see this graph. It talks about the latency and the throughput. Latency is basically the, again, the time taken. The lesser the latency, lesser the waiting time. That's what it means. So in this graph you can see the tokens per second. Here you can see Amazon, Bedrock is there, Azure is there, and here you can see 240 tokens per second. That's for Groq. If I'll just go ahead and see this one, output tokens per second. Azure, the OpenAI models or any models that we mostly use in Azure, that can create just 19 tokens per second, and in Groq we can create 241, and all the comparisons you can see here. I'll just go ahead and see. This is the seconds, to how many seconds basically each of these tools take to output 100 tokens. It is the highest. I think to output 100 tokens, Azure takes 10 seconds. See Groq, it doesn't even take 1 second. It is 0.8. This is insane, right? Okay, let me just go with the architecture of LPU, what goes around in the backend. So basically, when we talk about CPU and GPU, what is CPU? So central processing unit, basically we have limited cores, and each core is handling multiple tasks, and this multiple tasks are being handled by different threads. And this is not actually, these threads are sequential only, they are just utilizing each other's downtime. This is not the actual parallel processing, but again, these are They are sequential, but again they are utilizing the downtime of each other. So that's in a single core only there are multiple threads happening. And then we come then GPU comes, graphics processing unit, where we have multiple cores, and multiple cores are performing parallel processing. Multiple cores are each core in the multiple, all the cores that we have are assigned with a small task, and all these tasks are being handled by different cores parallelly. So that's what happens in GPU. So if I go on with the architecture, for example, if uh, if I just talk about GPU, so for example, this is the layer one. In the layer one, for example, we have the multiple cores. In layer two, we have memory controller. In layer 3, for example, we have something. Layer 4, in layer 5 we have CLI, maybe the unit that is responsible to connect the GPU with the rest of the computers. So these are different units, unit 1, unit 2. These are different units that are being designed to perform different tasks. This unit designed to do the parallel processing. This is the memory controller that basically manages the data flow of the whole architecture or the whole system. And that's how every unit has been designed. Now what happens with LPU? With language processing unit, again we have different units. The first unit is tokenizer. Second unit, embedding. Third unit, transformer, and so on. Again, multiple units. Unit 1, 2, 3, 4, and goes on. Now see both the architectures. In GPU, we have multi-parallel processing, memory controller. Even in LPU also, we have memory controller here, for example. So, but if you see the architecture of both the models, in GPU is more of a general purpose, but LPU we have, you can see a single unit has been designated just for tokenization. A single unit has been designated for just embedding. A single unit has been designated for transformers. So that is why each unit is specialized to do a particular task that makes the inferencing speed so faster. So yeah, that pretty much it from my side on Groq inferencing. Thank you.